All right, we're going to talk about polynomial and rational inequalities. So when we're looking at these, we are not looking at shading a part of an area. What we're looking at is what part of the graph is going to be positive and what part of the graph is going to be negative. Okay, so our first one here is our example is x squared minus 4x minus 5 is greater than 0. Okay. So I've already done this one out so that way we can kind of talk about it. So the first thing is I wanted to look at the graph of x squared minus 4x minus 5 equals y. So there's my graph. And what I'm looking at is I'm looking at these points where it equals 0 and then go from there. So I'm going to set this equal to 0 and solve. So I factored this into x minus 5 times x plus 1 equals 0. So I got my 2 points, my two points where it crosses the x-axis. Well, that sets me up into 3 different intervals. So it sets me up into negative infinity to negative 1, negative 5 to 5, 5 to infinity. And we're going to test it. Now from our graph, we already know that these are the two that actually are greater than 0, right? Because they're on the positive side of the x-axis. Or they end up having positive y's, is what I'm trying to say. But what we need to do is we need to test them. So to test this, what we're going to do is we're going to pick a value in each of these and test it. Okay? So on the first one, I'm going to pick negative 10. So I end up with negative 10 squared minus 40 times negative 10 times negative 5. Well, this is going to give me 100 plus 40 minus 5, which is 135. Is that greater than 0? Yes, that is. Okay, so this one is true. So that's just using a point in there to test it. Now I'm going to test a value between negative 1 and 5. So I'm going to pick 0. 0 squared minus 4 times 0 minus 5 equals negative 5. That is not greater than 0, so it fails. Then I'm going to pick a value between 5 and infinity. So I'll just pick 10. So 10 squared minus 4 times 10 minus 5. Well, that's going to give me 100 minus 45 or 55. That is greater than 10, so that's it. So my interval is parentheses negative infinity, comma negative 1 parentheses union parentheses 5, comma infinity parentheses. The reason I'm using parentheses on negative 1 and 5 is because it is strictly greater than. If it was greater than or equal to, I would then use my bracket. Okay, so our next one is a little bit different because I don't have it an inequality to 0. So the first thing I have to do is I have to get this to be in some regards to 0. So this gives me x squared plus 2x minus 8 is less or equal to 0. Now I want to know those points where it equals 0. So I'm going to factor this, x plus 4, x minus 2, and I'm going to set it equal to 0 because those are the points where it's going to cross the x-axis or actually be on the x-axis. Okay, so I end up with negative 4 and positive 2. Well, that sets up intervals. Okay, so now I have negative infinity to negative 4. This is going to be a bracket because remember I have equality here. Then I go from negative 4 to 2, and I go from 2 to infinity. And parenthesis there. And now I'm going to test to see which intervals this satisfies this. So I'm just going to pick a value here and plug it in here and see. So I'm going to plug in negative 10. Okay, so I have negative 10 squared plus 2 times negative 10 minus 8. That gives me 100 minus 28 or 72. Is that less than 0? No. So that one's done, right? Now I'm going to test this one. I'm going to pick 0. 0 squared plus 2 times 0 minus 8 is equal to negative 8. Is that less than or equal to 0? Yes. Okay, now I'm going to test my bottom one. I'll pick 10. 10 squared plus 2 times 10 minus 8 equals 100 plus 20 is 120 minus 8 is 112. that is not less than or equal to 0, so that one fails. So my only interval that is less than 0 is -4 to -2. Okay, bracket -4, comma, 2 bracket. All right? All right, so I'm going to erase this so I have a little bit more room here. All right, so now we're going to talk about rational functions. Well, rational functions, we're going to kind of treat them very similar to these other polynomial functions. So the first thing is I need to know where 3x plus 6 equals 0 or is undefined. Okay, so essentially what I'm going to do is I'm going to take the top, 3x, I'm going to set it equal to 0, and I'm going to take the bottom and set it equal to 0 and find those points. So here I have 0, here I have -6, right? Remember that this one here is never going to be in a bracket. It can never be in a bracket, okay? So now I'm going to set up my intervals. So I go from -∞ to -6. I go from -6 to 0. Now, is the 0 going to have a parenthesis or is it going to have a bracket? Well, let's look. It says strictly less than 0. Okay, since it's strictly less than, I'm going to have a parenthesis. Now I'm going to go 0 to infinity, and now I have to test them. Okay, so I may not spend a lot of time figuring out the exact value. I just want to know if this is going to be positive or negative. Okay, the reason is if I have it, if it's positive, it's not less than 0. If it's negative, it is. Okay, so I'm going to plug in, let's say, -10. Okay, I'm not going to actually find the value. I just know it's smaller than -6. So the top is going to be negative. The bottom is negative, so I have negative over negative, which makes it a positive. So this is positive. Does not work. So now I got to test between -6 and 0. Okay, so I'm going to think like kind of -1. So -1, I get negative over positive, which is negative. That one's going to work, right? Because it's negative. It's going to be less than 0. Here, I'm going to pick a value bigger than 0. Okay, so it's a positive number. So positive, positive. This is going to be positive. That one doesn't work. There is my only interval, -6 to 0. Okay, so that's just kind of using a little bit of mental math instead of like before where we actually physically got a number. We're just using mental math to see if it's positive or negative. That still gives us the correct answer. The last rational we're going to talk about is what happens when the rational expression is not less than or equal to or greater than or equal to 0. So the first thing is remember, I have to get this to be 0. Now, the reason I want it to be 0 is the problem is with 1, there's that infinite amount of values by 1. 0 is very definitive, right? If it's less than it, it has to be negative. If it's greater than it has to be positive. So it really helps us out here. Okay? So now I have this rational expression, this fraction minus this integer. Well, the first thing I want to do is I want to make this one rational expression. So my denominator here is 2x minus 4. So what I'm going to do is I'm going to go x plus 1, 2x minus 4 minus 2x minus 4 over 2x minus 4 is less or equal to 0. Okay, so I have x minus 2x is negative x. 1 minus a negative 4 is positive 5 over 2x minus 4 is less than or equal to 0. So now I'm going to take my top, I'm going to set it equal to 0. Negative x plus 5 equals 0, or x equals 5. I'm going to set my bottom equal to 0, 2x minus 4 equals 0, or x equals 2. Okay? So now I'm going to create my intervals. So I'm going to go from -∞ to 2, and this is going to be a parenthesis. Even though this is equal, this is parenthesis because remember, that's what makes the bottom 0, so I cannot have it. 2 comma 5, I'm going to have a bracket here because of the equality of my inequality there. Bracket 5 comma infinity parenthesis. Now, when we're here, there could be a lot more intervals. So like if this is a quadratic on top, I could have 2 different values up on top. So I could have 2 up here, 1 down here. So I would have 4 different intervals. I could have 2 on top, 2 on bottom, which would give me 5 different intervals. Okay, so these intervals can really, really get large. Okay, so I'm going to look at kind of this idea here. I'm going to pick a value. So I'm going to pick 0. So when I pick 0, I cover up my x's, right? I have 5 over negative 4. It's negative. So this one works, right? It's going to work. It's less than 0. So I know the first one works. Now I'm going to look at between 2 and 5. So if I get between 2 and 5, so let's just say I'm at 3. So if I plug in 3, the top is going to be positive, right? 5 minus 3 is positive. The bottom is 6 minus 4 is positive. So I have a positive over a positive, which is a positive. So these values are positive, but I have to be less than or equal to 0, so that doesn't work. And now I have 5 to infinity. So I'm going to pick a value that's we'll do 10 just to be there. 10, so the top is going to be negative. The bottom is going to be positive. So I have a negative over a positive, which gives me a negative. And there's my 2 pieces here. So now I have negative infinity to 2, bracket 5 to infinity. So there's my piece. So remember, when you're working with these, you want to kind of solve those out for 0.